Okay, so in this section, we are going to talk about multiplication properties of exponents. In the previous video, I mentioned the base. Remember the base, if I have x to the fourth power, the base is the x, the exponent is the 4, the whole thing is a power. Okay, so this only will play a factor is if our powers have the same base. If they don't have the same base, we cannot combine them. It's kind of like a like term situation. All right, so if we look at how we actually break up powers, x to the 6 is just x times x times x times x 6 times, right? And x to the fourth is x multiplied by itself 4 times. So if we think about it, here would be 6, 1, 2, 3, 4, 5, 6. This is my x to the 6, right? Because there's 6 of them. And then this, 1, 2, 3, 4, is my x to the fourth. So when I look at how many x's there are total, there's 10 of them. All right, so instead of breaking up like this every time, all we need to do, our rule is that we add the exponents if they're being multiplied together. So we have 6 plus 4 equals 10. Right? And that works even if it's a negative exponent. We talked yesterday about negative exponents and how we make them a positive by putting them on the opposite side of a fraction, but we can think of it this way. 4 plus a negative 3 would be 1. All right? And you can just type this, 4 plus negative 3, into your calculator and get that answer. All right, so whenever we have, and you can see here the base of this is 2, so we are allowed to do that. Here we have a base of 5. So since the base is the same, we're going to keep that, and then we just have to add the exponents. So 6 and 10 would be 16. So that would be to the 16th power. Here we have 3 powers with the same base. So 3 plus 4 plus 5, we can think of it that way, just like we break it up here. So we have 5 plus 4 is 9 plus 3 would be 12. So this would be x to the 12th power. Okay, so that is the general rule on how we would multiply exponents that have the same base. Now we're going to get into multiplying algebraic expressions. All right, so how we have to do this. Now, if I look at this example, it looks like it's 2x to the fifth and 3x to the negative third, which it is. But this is being multiplied by this. But in reality, the 2 is being multiplied by the x to the fifth, and the 3 is being multiplied by that x to the negative third. So we need to think of that 2 and x to the fifth as actually being their own separate terms, in a way. All right? So separate the numbers and variables that are multiplied together. When I mean separate them is you're going to see it like this, but visually think of it as 2 times this times that 3 times that. All right. Then what we do is anything that has the same base, we go back to our rule with adding the exponents, but our whole numbers we just multiply together. All right. So if you look at this example, I visually separated it from you, and then I put the 2 and the 3 together, which gives us our 6. 5 plus a negative 3 will give us x squared, and then we can smush them back together because 6 times x squared is written like that as well. All right, so let's try this one. So if I look at this, I'm going to rewrite my 5 here. So 5 times 2 times 3, and then times, I have an x here, I have an x here, so x to the 8th, and I have a y to the 4th. Now remember, if you don't see an exponent, we talked about this the other day, we think of it as a 1. Just like all of these have a little exponent of 1 next to them. Again, this doesn't apply for that, but we're thinking of it that way. All right, I'm going to bring up the Desmos Calculator. So this is just showing how we're going to do this. So I'm just going to multiply these numbers together. So 5 times 2 times 3, that gives us 30. All right, so we have 30, which is that part. Remember that 5 times 2 times 3. And then we have an x to the first and an x to the 8th. 8 plus 1 is 9, so that's going to give us x to the 9th. And then y to the 4th doesn't have any other bases that it can add to, so it just remains like that. And that would be our expression simplified. So go ahead and pause this or follow along with your notes, but let's practice these. So if I look at this one, I have a 7. Remember, I'm going to think of that as 7 times n. Even though it's not separated by a dot like it is here, think of it like it is. So I have my 7, then I have my n squared, n third, and n, and again, that's to the first power. So I'm going to write that 7 down. There's nothing else that multiplies with it. 2 plus 3 plus 1. 2 plus 3 is 5. Plus 1 is 6. So n to the 6th power would be my answer for that one. All right, now as you get comfortable with these, and I see this, instead of rewriting it, maybe I just say 2 times 7 times 2. All right, so 2 times 7 times 2, there's my whole numbers, gives me 28. So I have 28. Now look at your variables. Now typically in standard form we list it alphabetical, so I do the x's before the y's. So I have an x. There's no other x's in this problem, so that's just going to remain x to the 2nd power. And then we have a y to the 3rd and a y to the 4th. 4 plus 3, right? So we do y to the 7th power. That is our final answer. All right, now we look at this one. Now notice there's only one whole number, so I'm going to put that out front. I have an m to the 2nd power, and this is an m to the 1st power. So that's going to give us m to the 3rd power, because I'm adding those together. And then I have my n to the negative 2nd power. Now, as your answers are progressing, you are going to need to make this a positive, because that was the rule we learned the other day. So I'm going to rewrite this as 7m to the 3rd, which would be on the top of the fraction. And to make this a positive, we move it to the bottom of the fraction. So n squared. So that would be my final answer, and using only positive exponents. So those rules still apply. And if you think about back to the problems that we did yesterday or a couple days ago or whatever, whoever's watching this video in whatever sequence, we talked about how to make them positive by moving them to the opposite ends of the fraction bar. All right, so that is the lesson on how to multiply exponents that have the same base. So basically all you're doing is you're adding the exponents as long as they have the same base. If they do not have the same base, you just list them next to each other because you cannot simplify them any further.